Okay, these are the class notes for the word problems from section 1.1. I have them filled out because I've done this already, and it was 16 minutes, almost 17 minutes, and too long for me to put on YouTube. So here's the shorter version. We have a rectangular room. It's twice as long as it is wide, and its perimeter is 84 feet, and we want to find the area of the room. I like to draw a picture. So rectangle, label length and width, and we know that the length is twice the width, so we have that little equation right there. Perimeter is 2 length plus 2 width. Substitute everything in and solve, and we get the width to be 14, whatever, I guess it's feet. Didn't have that on there. So then our length is twice the width, so twice of 14, so that's 28 feet. And then the question asks for area. It doesn't ask what length and width are. So area of a rectangle is length times width. So that's 28 times 14. And if we multiply those together, we get 392 feet squared is our area. For our second problem, the sum of 3 consecutive integers is 231. What are those 3 integers? So we have to set up some variables. So I'm going to let n equal our first integer, and then n plus 1 is going to be our second integer, and n plus 2 is going to be our third. So for example, if our first integer was 2, our next consecutive integer would be 3, so that's 1 more. And then our third consecutive integer would be 4, so that's 2 more than the first integer. So that's how we set up each one of those little equations. So then expression. So our total equation is n plus 1 plus n plus 2 is equal to 231. The parentheses aren't really necessary, but it just lets you see that you're adding 3 different integers together, or expressions for integers. Combine like terms. 3n plus 3 is equal to 231. Subtract 3 from both sides and then divide by 3. We get our first integer to be 76. So that means our 3 integers are 76, 77, 78. And just as a double check, make sure you add those up and they should equal 231. Okay, next example. Whoops. We're on a Canadian freeway. Our total trip is 300 kilometers from our home. After we're driving for 30 minutes, we pass an exit that we know is 50 kilometers from our home. If we're traveling at a constant speed, how long will it take for the entire trip? So we're going to break this into 2 different parts. I like to draw a little picture. Here's the start, which represents home. And then here's our end, which is 300 miles. That's our finish. And we know after 50 kilometers that time is 30 minutes from our house. So we're going to use the formula distance is equal to rate times time. Well, for the first part of the trip, we know our distance is 50 and we know our rate is half of an hour. And we're going to change that 30 minutes to 0.5 of an hour or half of an hour. And that way we can figure out what our constant rate is. And when we solve that, we get 100 kilometers per hour. Now we can then apply that rate to our total trip. So our total distance is 300. At 100 miles per hour, we can now figure out our time, which is 3 hours. Okay, last 2 problems are mixture problems. First, mixture. We are mixing together 2 different types of candy. One mixture is $2.49 a pound and the other one is $3.89 a pound. So if we mix them, we're going to get a mixture that's in between those 2 prices. And it says we end up with 50 pounds that cost $3.19 per pound. Again, a little picture is helpful. So here's my little candy bag. 50 pounds at $3.19 per pound. My first part of my mixture is candy corn. It's at $2.49 a pound, but I don't know how many pounds that is, so I'm going to call that X. That's my variable. And then I'm mixing that with peanuts, which are $3.89 per pound, and we don't know how many pounds we have of that, so I'm going to label it Y. If you've ever tried it, candy corn and peanuts, try those together. That tastes like a Payday candy bar. I don't know, just a side note there. So we need a system of equations, and we know that the amount of candy corn and peanuts is equal to 50 pounds. So that's x plus y is equal to 50. And then we need an expression to represent the cost. Well, it's $2.49 for the candy corn plus $3.89 for the number of pounds of peanuts, and that's going to equal our mixture price of $3.19 at 50 pounds. So there's our system of equations. It's easiest to solve the first equation for either x or y. It doesn't really matter. And then we substitute that value back into the second equation, distribute, combine like terms, move everything over, or everything except for the y terms over to the other side, and then divide, and we get y to be 25 pounds. So if we know y is 25 pounds, we can use our equation from above. X is equal to 50 minus y. So that's 50 minus 25. And we end up with 25 pounds of candy corn. So we have 25 pounds of each item to make up our mixture. Same concept when we're mixing two solutions of hydrochloric acid. One's 10% and one's 30% solution. And we need to create a mixture that's 25% solution. So logically, we know we're going to have more of the 30% solution than the 10% because our mixture is 25. 25 is closer to 30. So again, if you draw a little picture, here's our mixture of our little bubbly hydrochloric acid. It's 25% at 100 milliliters. Solution A is our 10% solution. We don't know how much we have, so I'm going to call that A. Here's solution B. It's at 30%. I don't know how much I have of that, so I'm going to label that B. And again, we're going to set up a system of equations. We know our two solutions together, 10% and 30%, solution A and B, is going to add up to 100 milliliters. And then we have 10% solution times how many milliliters plus 30% solution times number of milliliters is equal to our 25% solution, which we know we have 100 milliliters of. Again, take the first equation, solve for a variable, so I solve for A, substitute that into the second equation, combine like terms, solve, all that kind of good stuff, and we do see that we end up with 75 milliliters of solution B, which we said made sense, and then we can calculate and end up with 25 milliliters of solution A. So I hope to see everybody tomorrow, and we'll get caught back up. See you soon. Bye.